Okay, hi class. So let's continue. All right, so just now you have learned how to find the inverse of a matrix by using the elementary row operation, right? Okay, now we will see some concept about the inverse of the matrix theorem. Okay, so just one theorem. Okay, if matrix A and matrix B are non-singular matrices, all right, means has inverse lah, of order n by n, so it's a square matrices, then the product matrix AB will has an inverse matrix given by this. The inverse of this matrix AB will be inverse B multiplied inverse A. So this one is a new matrix. When A multiplied B, it will get a new matrix. So the inverse of this new matrix will same as inverse B multiplied inverse A. All right, so let's see how we are going to prove this theorem. Okay. So it's like this. All right. We start with this one. Let's say matrix AB multiplied with inverse B inverse A. So just start with this one. So later we will see why we start with this. Okay, so because of the multiplication of the matrices are associative, remember associative, so means we can just remove all the brackets, all right, and we can write the brackets wherever we want, not changing the position of the matrices, all right, just put the bracket according to what we want. So when we remove all the brackets, it become A, B inverse A, all right, so I bracket here so that it become together. So B inverse B is I, all right, any matrix multiplied with I, you get the original, get back the matrix. So A inverse A, you get I. So this matrix multiplied with this one equals to I. All right, then we do the other way around. Just now is AB multiplied with this. Now in another way, inverse B inverse A will multiply with AB. So same, by using the associative law for matrices, all right, we can remove all the brackets. Then we put the brackets here. So again, inverse A multiplied with A, you get I. Any matrix multiplied with I, you get back the original matrix. So inverse B, B will be I. All right, so from these two results, so we can say that AB multiplied with inverse B inverse A, you get I. And also same as this one. Right? So therefore, we can say that based on the concept of this matrix multiplied with its inverse, we'll get I. Based on this concept, the original basic concept of matrices, therefore, we can say that the inverse of this matrix will be same as this one. Right? Because when this multiplied this, you get I. So means the inverse of this one is this one. So the inverse of AB is same as inverse B inverse A. Okay, this is how we prove this theorem. So remember, inverse of AB is inverse B inverse A, not inverse A, not inverse A inverse B. Okay, so we can extend this theorem to 3, to 3 ABC. Just now 2 only, right? AB. Okay, we can extend this to 3 matrices. So to find the inverse of product ABC, all right, so we, as I said, because of the associative law, we can put a bracket wherever you want. So I put a big bracket for this one, so I can bracket up this one. All right, assume this is a product lah, so you get a new matrix here. So the inverse of A, B, and C will be same as, we use this theorem. All right, we use this theorem. So will be inverse C multiplied inverse B. All right, so this one copy. And inverse AB is inverse B inverse A. Therefore, we get a concept that the inverse of ABC same as inverse C inverse B inverse A. Okay, so this is a concept that we can use for this inverse of matrix. All right. So we will have one question. So far, only one question came out in STPM, which is STPM 2005. All right, and I can't find any other example other than this. Okay, so never mind, we are using this, where this question will apply this concept, this theorem. All right, so you see, you are given three matrices A, B, and C. They are all square matrices such that BA equals inverse B. All this is given. And ABC is same as inverse AB. This is also given. All right, so the next step is you're asking to show this thing. Show that inverse A same as B square, same as C. Only 3 marks. Okay, so we are going to use the concept lah. So it is like this. Okay. All right, we will start with this. Given BA equals inverse B. We start with this. This is given. All right, so because I want to show B square ma. All right, so I multiplied B to both sides. So see again, I put the B at the left hand side for each. All right, so this one you get B square A lo. This one you get I lo. All right, then I don't want the A ma. So I want to remove the A, so I multiply inverse A to both sides. So now you see I put the inverse A at the right hand side. So at the right hand side also. Okay, so this one will become I. So any matrix multiplied with I, you get back the matrix. Therefore, this one also. So B square equals inverse A. Alright, so this is the first part we show. Okay, what else to show the next one? Because we want to show this one. I only show this part only. So we need to show this. So I use another statement given to us. ABC equals inverse AB. So we start with this. Alright, so by using associative law, so I can put a bracket for this one. I just put the bracket here. Alright. Then because I want to remove this one, I want to find C only. So I want to remove this one. So I multiply with the inverse of AB law. This one copy. So I multiply inverse of AB at this side. Alright, so inverse AB multiply AB. So I law. C. This one because of using the theorem that we are proving just now. Using this theorem. So inverse of AB is inverse B inverse A. So inverse of AB is inverse B inverse A. Okay? Then next step is just now we already show here. Inverse A is B square, BB. Inverse A is BB. So all the inverse A, I change to BB. Inverse A, I change to BB. Okay, so I get this thing. So this inverse BB become I. This inverse B and inverse B also I. So this one is B square. So I B square, left B square lah. This one also. C multiplied with I, C. Alright, so let's say this is 1 and 2. So when we combine 1 and 2, so inverse A equals B square and B square equals C. Yes, we have proof. Alright, only 3 marks for this one. Okay, so the next part is you are given matrix B. Okay, find C and A. I'm not going to show this one. You have to do yourself. Alright, since B is given, we can find C easily, right? By using this one. So C is equals B square ma. So C equals B square. Just do the multiplication and you get this thing. Alright? And after you get C, alright, we only have inverse A. I'm using the concept, I'm using this part. Inverse A equals C. Alright? So from here, means that C you have here already ma. So it means you have the inverse A already. So when you have inverse A, can you find A? Yeah, same like this one. Same like what you have done. Alright, using the elementary row operation. Alright, you have inverse A, you can find your A. Same method. Before this, what we have done is they give you A, you find inverse A. Alright, now you have inverse A, you do the same thing to find A by using elementary row operation. Okay, so these two parts I want you to complete at home lah. 7 marks. Okay, so I just want to show you the example how we use the theorem for the inverse matrix. Okay, all right. Okay, now we go to the last part of this chapter, 3.4. System of linear equations. This is a very popular part. Almost every year, there is a question from this part. All right, means that we are using matrix to solve linear equations. Okay, so first we have to see how many the types of solutions that we can find. 3.4.1, unique, inconsistent, and infinite solutions. So we have three types of solutions. All right. So I use a simpler example to explain. Let's say I use two only. Okay. If two-dimensional geometry, when two lines means two linear equation like this All right, are given, so they must be either intersecting, parallel, or coincident, right? So how this three condition looks like? Okay, we look at the first one. If you are given two lines or two linear equations, if they are intersecting, means like this, or they cross each other, right? So when they cross each other, it means that there is only one point of intersection. All right, this one, this point. So the system said to be has a unique solution. All right, one answer one set of answer only xy. So unique solution, and when it has unique solution, we say that the system is consistent. All right, this is the first condition, the first situation. Okay, second one is parallel. So if you are given two lines which are parallel means their gradient are the same. All right, just different intersection. This is minus, please change it. This is minus. All right, so it will be like this. Two lines parallel, no intersection, right? So if no intersection means no solution. So you see, there is no point of intersection. Therefore, the system has no solution. When no solution, it's said to be inconsistent. The system is inconsistent. All right? Okay, so I repeat. When it is intersecting, so you have one unit solution and the system is consistent. When they are parallel, so there is no solution and the system is said to be inconsistent. All right? And the third one, if two lines are coincident. Coincident means they overlap each other. Let's say these are two equations given to you, and actually they are overlapping. These two lines, when you draw, they are overlapping like this. Okay, so when this happens, we say that this is infinitely many points of intersection, right? So all the points on the line are intersect each other. So there's infinitely many points of intersection. Okay, so if this happens, we say that the system has an infinite number of solutions, or we say infinite many solutions. Okay, and the system will say to be consistent. All right, so make it clear these three concepts, because after that we are going to do it. All right. Okay, so as a conclusion, this one. All right, so the system can have two. The system, a system of linear equations, either two or three. So either they are consistent or inconsistent. All right, if inconsistent, very simple, means no solution. But if consistent, means has solution. And it has two conditions. One is unique solution, only one solution, and one is infinite many solution. This is like conclusion of this part, right? All right, so after we have understand the type of solutions, okay, now we will see system of linear equations in matrix notation. Matrix notation. Okay, let's say you are given a system of linear equations of three unknowns, x, y, and z. Okay, like this. You are given three linear equations which involve three unknowns, x, y, z. All right, so the above equation can be solved by using method of substitution or by eliminating either two of the three unknowns. You have done this method in chapter 1. All All right, if you forgot, please go back and refer back your chapter 1 notes. Okay, solving equations, 3 linear equations by using algebraic method. All right, now we are going to use matrix method to solve this, to find x, y, z. All right, so another method that can be used to solve the system of linear equations is by the matrix method. So this means that the above system of linear equation can be written as a matrix equation as follow. Matrix equation. This is matrix equation. So when the question wants you to express it in matrix equation form, this is how you should write. All right, so the first 3 by 3 matrix will be all the coefficient of x, y, z. See or not? Coefficient of x is A1. Coefficient of y is B1. Coefficient for z is C1. So A1, B1, C1 will become your first row. A2, B2, C2, second row. A3, B3, C3, third row. All right, and the variables you write in another matrix, x, y, z. All right, and the solution here, you write it in any other matrix. Okay, so this is what we mean matrix equation. Okay, so actually you can see when we do the multiplication, remember first row times first column, right? First row times first column. So A1x plus B1y plus C1z equals to D1. You get back the equation? See that? They are the same. Okay, then next will be, let's say when I write in this form, let's say this is matrix A lah, and this is matrix X, right? And this is matrix B. So it's in the form of A multiply X equals B. All right, why I write like this? So I want to show you by using matrix how we can find X, Y, Z. All right. So this one is repeat like just now. This is A, this is X, this is B. Okay? So the system of linear equation now can be written in AX plus AX equals B, like what I have done just now here. This is a meaning A, X equals B. Alright? Then the matrix A, this one, is called the matrix of coefficients. Right? Just now I already told you that it is the coefficient of all the x, y, z in all the 3 equations, right? Okay. Now, after we have done this, how we are going to solve for matrix X? Or how we are going to find x, y, z? Okay, so since A is non-singular, means the inverse axis lah, So by pre-multiply both sides of the equation by inverse A, so we will be like this. Just now is AX equals B ma. So I multiply inverse A to both sides. Alright, so using the associative property, I can remove this bracket and put wherever I want. Alright, so inverse A is I lah. And when I, this is the inverse property. This is the inverse property. And when I multiply with X, you get back X. This is identity property. So from here you see, I can find matrix X by multiplying inverse A to B. So of course you need inverse A lah. So by comparing the corresponding element in both X and inverse AB, so the values of X, Y, Z can be found. We can use elementary row operation to find inverse A, and finding the unit solution of the system of this linear equation by using the inverse matrix. It depends what the question given to you. Alright, some question they will give you something so that you can find the inverse easily without going through the long steps. But some not, some you have to find. Okay, so this is how we solve a system of linear equation by using the matrix way. Alright, so we will see some examples. Okay, so example of 3.4.3. Question 1. Alright, solve the following system of linear equation. I solve 2 first. Before we go to 3. This one I just solve and show you the type of solutions only. I don't use the matrix way. I don't use the matrix way. Okay, so these are the solutions. Okay, can see. Okay. So these are the solutions. Question 1a, solve these two. So equation 1, equation 2. So I multiply equation 2 by 5. So 15 minus 5, 35. Why multiply 5? Because I want to eliminate. So 3 minus 1. So this one minus this one. Negative 5y minus negative 5y, no more y. This one minus this one, 26. So x equals 2. Alright, then of course you can find your y lah. So we call it unique solution. You only have one set of answer, x and y. Okay, question 1b. Alright, 1b, you are given these two. Alright, so when I use equation 1 times 2, so I get this thing. So when I get this, you see that second and third are the same. Second and third actually are the same. So same means like what we have discussed just now. It is coincident. This one. They are actually overlapping each other. Alright, so when this happen, so we say that it has infinite many solutions. What is the meaning of infinite many solution? Very simple. For example, when you sub in x equals 1, so your y will be 2/3. When you sub in x equals 2, your y is 0. When you sub in x equals 3, your y is negative 2/3. You see? And so on. Many. You can have many solutions. Alright? So second is the example for infinite many solutions. Alright? Okay, and C. Alright, so the question for C. Alright, so you are given these two equations. So I use 1 times 2, so I get this. Alright, so I use 2 minus 3. So 2 minus 3, 2x minus 2x, 0. 4y minus 4y, 0. 3 minus 2 is 1. So, you see, we said it contra. Left hand side is 0, right hand side 1. Cannot, right? Cannot happen. Cannot be. So, contra. So, if contra means no solution, so for this system of linear equation, there is no solutions. Alright? Okay. Okay, now we will, checkpoint 3.4, this one will be your homework lah, all this will be your homework. Okay, we will see one STPM question. Question 3. Okay, STPM 2007. So you are given matrix A and matrix B. Okay, find the matrix A square B. Then from here, you deduce the inverse of A. From this answer, you deduce inverse of A. Okay, so of course, as I say, to find A square B, you have many ways to do it. You see, before this, I do it this way. I find A square first, because A square B ma. I find A square first, then I multiply with B. Then I get this answer. Okay, why I don't use this one? Actually, same. Why I don't use this one? Because after that, I found that they say they want to find the inverse of A. So, if you want to find the inverse of A, it should be in this form. See that? So if I find A square first, then only multiply B, then later I have to do another time to find AB. So it more works. You still get the same answer. Alright, but just more works. Okay? Since because of this, alright, so I redo it. Okay, I redo it. And I find AB first. Because A square B means AAB ma. So I find this one first. I find AB first. So AB, matrix A, matrix B. So you do all the multiplication and you get this. So this is my AB. Alright, after I get my AB, so A square B is AAB ma. So this is your A, this is AB. Alright, so after I multiply, I get this. You see? Actually, they have the same answer, right? Actually, they have the same answer for A square B. The answers are the same. Either you find A square first, multiply with B, or I find AB first, then multiply with A. You still get the same answer. Alright, remember associative law. This is associative law. Okay? So this is what the question want. So actually our stop here to find a square b. Or the step stop here. Then after that they want us to deduce the inverse. Deduce means from this answer. So you see all 1 2 1, right? I factorize out 1 2 1. Okay, so it is equals to 1 2 1 I. This is identity, right? Identity matrix. So I. Alright, so from here I get AB, or a square b is AAB equals to 1 2 1 I. Okay, so this 1 2 1 I can shift it to this side, become 1 over 1 2 1. And remember, because this is a number, so I can put wherever I want. So I decide to put it here. Alright, so it becomes A multiplied with this matrix equals I. Alright, so again, since A inverse A equals I, so very clear that if this is A, this is your inverse A. Alright, so this is your inverse A. Don't stop here. The question wants you to find inverse A. So don't stop here. So we continue. You continue. Alright. Therefore, inverse A is 1 over 1 2 1 multiplied with your AB. AB. This is why just now I calculate AB first. So I don't have to redo. I can use here. Alright. So multiplied with your AB. Then you get this. This is your inverse A. It must be in full, like this. Okay. So after you get your inverse A, okay, the next step is hence solve the system of linear equation. So you see, you are given a system of linear equation. You are given 3 linear equations in x, y, z. Alright, so since we have done this part and you're asking to solve, definitely the coefficient for x, y, z, okay, the coefficient for x, y, z will form one matrix like A, because we have inverse A ma. It should be something that like A. Okay, so let's check. The first one is x minus 2y minus 7 equals negative 8. So it's 1 minus 2 minus 7. This is our A. I copy again here so you can see easily. Z. This is not 7. This is Z. Alright, so this is 1, negative 2, negative 1. So which line is 1, negative 2, negative 1? It seems like this one, right? The first row of A. But this is negative 1, 2, 1. This is 1, negative 2, negative 1. So you can rearrange it. You rearrange from here. So I multiply this equation by negative 1. So this one becomes negative x, positive 2y, positive z, positive 8. Alright, now you see it's in the form negative 1, 2, 1, which is your first row. See or not? Okay. Second one, 3, negative 1, negative 4. 3, negative 1, negative 4. It seems like equivalent to this, but the sign different. The sign different. So again, you multiply with negative 1. So become negative 3x, positive y, positive 4z, positive 15. Now the coefficient is negative 3, 1, 4. Same as your second row of A. Alright, and this one no problem. This one just copy. No x means the coefficient is 0 No x means the coefficient for x is 0. So 0, 1, 2. Yes, third line. Okay, this is how we transform. You are given a system of linear equations. So make sure you rearrange it until you get it same as the equation that you are given before. Okay, now we transform it into the matrix equation. Must write in this form, matrix equation. So write down all the coefficient here, the variable x, y, z, and the solution 8, 15, 4. Alright, so this is matrix A. This is your matrix X. So this one I name it as matrix C . I don't name it as B because you have one B here. I don't want you to confuse. Alright, so same like just now. All these steps you must show in the exam. Okay, I want to find X, so I don't want A. So I multiply inverse A to both sides. Alright, so this one become I. Alright, this one become I. So X, where? Okay, here. X. So x equals inverse A, C. So now inverse A, I can use, I see all this fraction. When we multiply, it will be very complicated, right? So since I see my inverse A has all the 1 over 11, so I actually factorize out the 1 over 11 and left all the integers. This is your inverse A. Okay, multiplied with a C. Then you do first row, first column, second row, first column, third row, first column. Alright? Easier ma. If all fraction, then it become all fraction like very messy. Okay, and now only you multiply in the fraction. So this is the answer I get for matrix X. So it means that your X is -3, Y is 2, and Z is 1. Unique solution. See that? We call this unique solutions. Alright? So a question like this give you 10 marks. Alright, so the important thing is when a system of linear equation given to you, you see whether fit to the matrix that you are using or not. Alright? Okay. Going up already. Okay. Alright. Okay. Okay. Okay, next. Alright, so question 4 also you do as homework. This one you are given PQR. The question you want to find PQ and also PQR. From these two answers, deduce the inverse of PQ. Actually same like just now lah. Then solve this linear equation. Okay. So I'm good. So because it's not difficult lah, so it's not difficult. So after this, okay, so immediately after this lesson, I want you to do question 5 as quiz. Alright, question 5 as quiz. Then you forward into the Google Drive that I give it to you. Alright, so after you complete, then only you continue another video. Alright, okay, see you later. Okay, bye.